Hi everyone, in this video I would like to share a few questions and answers on impulse and impulsive force. A 60 kg resident jumps from the first floor of a burning house. His velocity just before landing on the ground is 6 meters per second. Okay, the information given from the question is mass and velocity just before landing, 6 meters per second. So mass is 60 kilogram, and this 6 meters per second velocity just before landing means that final velocity. Okay, any velocity stated just before landings, actually that is v. U is always from the question, a 60 kg resident jumps from the first floor, means that before it jumps the initial velocity is equal to 0, and velocity just before landing is final velocity. So we have to bear in mind about that information. A. Calculate the impulse when his legs hit the ground. Okay, what is the formula for impulse? Impulse is equal to Ft equal to mv minus mu. We can use the formula impulse is equal to mv minus mu. The mass given is 60 kg and v is 6, while this mass is also 60 but the initial velocity is 0, so this is 0. So 60 times 6 is equal to 360. Unit for impulse is Newton second. Okay, let me show how to get Ft equal to mv minus mu. F is Newton, T is second. So this is the unit for impulse. At the same time, impulse also have the unit. Mass is kilogram, velocity is meter second negative 1. So this is also the unit for impulse. So question B, what is the impulsive force on the resident's leg if he bends upon landing and takes 0.5 seconds to stop? Okay, so highlight the information given. Time is 0.5 seconds, and the question asks impulsive force. So impulsive, there is impulse and impulsive force. So formula for impulsive force equal to mv minus mu divided by t. Any names that end with force, impulsive force, so the symbol is F, while impulse is Ft, impulsive force is F. Okay, so the mass given is 60 kg, the final velocity is 6, and the time taken is 0.5 seconds. So finally the answer is 360 divided by 0.5. So we have 720 Newton. Okay, this is question A, this is B, and now let's answer the question C. What is the impulsive force? Again, impulsive force on the resident's legs if he does not bend and stops in 0.05 seconds. Okay, so C, impulsive force is F equal to mv minus mu divided by time. So mass given is 60 kg. Final velocity is 6 minus 0 because initial velocity is 0 divided by time 0.05 second. So the answer is 7,200 Newton. Next question. What is the advantage of bending his legs upon landing? Okay, this question actually they want us to compare between B and C. Okay, B stated that B. Okay, let's read again the question B. What is the impulsive force on the resident's legs if he bends? Okay, yani this one he bends upon landing and takes 0.5 seconds to stop. Compared to C, what is the impulsive force on the resident's legs if he does not bend and stops in 0.05 seconds? If he bends, he takes longer time. The time is greater. And if he does not bend the legs, the time is shorter. Okay, the difference between bending of legs and not bend is time. If he bends, he takes longer time to stop. If he does not bend, he takes shorter time to stop. So how to answer the question D? What is the advantage of bending his legs upon landing? The answer is he increase the time of impact if he bends his legs upon landing. Okay, if he takes 0.5 seconds, the impulsive force produced is only 720 Newton. Compared to C, when he does not bend his legs, the time taken is only 0.05 seconds to stop. And the impulsive force produced is 7,200. 7,200 is much more greater than 720. So the force produced when he does not bend is so much greater than if he bends the legs. So if he bends the legs, he increased the time of impact. So when he increased the time of impact, he also reduced the impulsive force. Then less injury, because 720 Newton is smaller than 7,200. So if he bends the legs upon landing, he takes greater time, then the impulsive force is reduced. So the lesser the impulsive force, the lesser the injury it will cause. But the most important thing is you have to alert with the formula, impulse and impulsive force, and what is the importance of bending the legs upon landing, because bending the legs upon landing can increase the time of collision. Thus, the impulsive force produced is less, so less injury will occur. Okay, that's all for question number 1. Okay, let's read the question number 2. Ronnie kicks a ball with a force of 1,500 Newton. The time of contact of his boot with the ball is 0.01 second. Okay, let's highlight the information. What is the impulse delivered? The question asks the impulse delivered to the ball. If the mass of the ball is 0.5 kilogram, what is the velocity of the ball? So here question asking 2. First is this is question number 1, impulse, and question number 2 is velocity. So first of all, we have to recall the formula for impulse. Impulse is equal to Ft equal to mv minus mu. Okay, so let's answer the first question. The information given is force equal to 1,500 Newton, time of contact is 0.01 second. So we have F and we have T, means that we have Ft, so we can answer the impulse. So question number 1, impulse is equal to Ft. F is 1,500 Newton, T is 0.01 second. So the answer is 15 Newton second. Next question, if the mass of the ball, okay, now mass of the ball is 0.5 kilogram, what is the velocity of the ball? So question asking the velocity. Velocity have in this mv minus mu. So question number 2, impulse equal to mv minus mu. And as usual, u is 0 because Ronnie kicks a ball, means that before he kicks, the ball is not moving at all. So the impulse we have got from the first question, which is 15 Newton second, and the mass is 0.5 kilogram, and V is the question asking. So in order to find the V, 15 divided by 0.5, then we can find V. So V equal to 15 divided by 0.5 equal to 30 meter per second. So this is how to answer this question. We can use impulse equal to Ft, or we can use impulse equal to mv minus mu, or Ft equal to mv minus mu. Either way we can choose. Okay, that's all question number 2. Let's move on to question number 3. So this is question number 3. Let's read the question first. A trolley with a mass of 500 gram. Okay, 500 gram mass. Oops. Mass equal to 500 gram. As usual, we have to convert into SI unit. So 500 gram equal to 0.5 kilogram. Is at rest. At rest means that U equal to 0 on a smooth surface. The trolley is given a horizontal impulse of 5 Newton second. So impulse 5 Newton second. Okay, what is the velocity of the trolley after impact? So the question asking the velocity. What is the velocity? So when there is v, so we have to use formula impulse equal to mv minus mu. Since the question said trolley is start from rest, so u is 0 and the impulse is given 5 Newton second equal to mass 0.5 kilogram times v. So v is equal to 5 divided by 0.5 equal to 10 meter per second. So that's all. Okay, next question is question number 4. A horizontal impulse of 500 Newton second. So impulse is 500 Newton second is exerted on a stationary trolley. Stationary trolley means that u is 0 with a mass of 2 kilogram. So mass is 2 kilogram. What is the velocity of the trolley after the impact? So what is v? So obviously the formula we have to use is impulse equal to mv minus mu, and as stated in the question, it's start from stationary means that u is 0, so mu is 0. The impulse given is 500 Newton second equal to mv. So let's substitute. The mass is 2 kilogram and v is the unknown. So v equal to 500 divided by 2, we get 250 meter per second. So this is the final answer. The final answer must be right with the correct SI unit. A rocket of 50 kilogram, mass is 50 kilogram, is launched vertically. Its fuel is being burnt at a rate of 2 kg per second. 2 kg per second means that mass divided by time. Mass divided by time is equal to 2 kg second negative 1. And its exhaust gas is being forced out with a speed of 1000 meter per second. So v is equal to 1000 meter per second. What is the initial acceleration of the rocket? So what is the acceleration? As usual, u is 0 because it's launched. Before it's launched means that initial is 0. Okay, so the question asks what is the initial acceleration? Means that we have to use the formula ft equal to mv minus mu, and for your information, f is equal to ma. As usual, u is 0, so we can cancel this one because it is 0. Finally, we have ft equal to mv. Okay, as the information given, we have this one. Okay, m divided by time. So we have to transfer this time to here. So f equal to m over t times v. So m over t is 2 kg second negative 1 and V is 1000 meter per second. So F is equal to MA. So we substitute MA into F. MA. We solve this one first. 1000 times 2 equal to 2000. 2000 kg ms negative 2 or Newton. The question asks the acceleration. So acceleration, we only want A, so means that M here has to transfer to here. So 2000 kg ms negative 2 divided by mass. The mass given is 50 kilogram. So kg is cancelled. The answer is 2000 divided by 50 equal to 40. So the unit left is ms negative